Good afternoon to all of you. First of all, I want to introduce myself. I am Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering, and today I will explain to you GTU question paper with solution of November to December 2010 of the subject of vector calculus and linear algebra. So let's start. Here is the content GTU paper solution November December 2010 of the subject of vector calculus and linear algebra. First question 1a. First part. Verify Cauchy-Schwarz inequality for the given vectors where u is equal to -4, 2, 1 and v is equal to 8, -4, -2. Now first of all, to verify Cauchy-Schwarz inequality, at least you should know that what is a Cauchy-Schwarz inequality, right? What is Cauchy-Schwarz inequality? Which is a modulus of inner product of any two vector that is always less or equal to norm of product of norm of that two vectors. That means modulus of inner product uv, which is always less or equal to norm u dot norm v, that we have to prove particular for these two vectors u and v, right? And here we use Euclidean inner product, that is not mentioned, but let us assume that we have to use Euclidean inner product. So u is equal to -4 to 1, v is 8 -4 -2. So inner product uv, which is equal to -4 to 1 dot 8 -4 -2. So just simply dot product, use simply dot product. So -4 into 8, that is -32, 2 into -4, that is -8, -2, that is equal to -42. So inner product uv is equal to minus modulus of inner product uv, which is equal to modulus of -42, that is equal to 42, right? So left hand side is 42. Now try to find right hand side, norm u, product of norm u and product of norm of u and v. So first of all, norm u. Now we know that if u is equal to x1 x2 up to xn in Rn, then norm u with Euclidean inner product, how we define norm u is equal to under root x1 square plus x2 square up to xn square. So we use same thing here. Norm u is equal to under root -4 square plus 2 square plus 1 square, that is equal to under root -16 plus 4 plus 1, that is equal to under root 21. Okay, and norm v, similarly we find norm v. Norm v is equal to under root 8 square plus 4 square plus 2 square. So 64 plus 16 plus 4, that is equal to under root 84. Okay, so norm u dot norm v equal to under root 21 dot under root 84, that is equal to under root 1764, that is equal to 42. Okay, so you can see the left hand side is also 42 and right hand side also we got 42, and that is always 42 always less or equal to 42, that we can say. So here we prove the Cauchy-Schwarz inequality for particular this two vector u and v, that modulus of inner product uv is less or equal to norm u dot norm v. Okay, because left hand side we will get we got 42 and right hand side also we got 42. So Cauchy-Schwarz inequality is verified for these two vectors. Okay, so let's next and this question asking 2 marks in this question paper. Let's solve another example, question 1a, second part. Use the inner product pq, that is defined equal to integration from -1 to 1 px into qx dx to compute inner product pq for vectors px is equal to 1 minus x plus x square plus 5x cube, and qx is equal to x minus 3x square in P3. Now P3, the meaning of P3 is set of polynomial of third degree. Okay, the meaning of P3 is set of polynomial of third degree. So what we have to find here, we want to find inner product PQ, where P and Q already defined, that is polynomial of P3, and inner product is also defined. We use this integration from minus 1 to 1 px qx dx. Okay, so let's start solution. Inner product PQ is equal to integration from minus 1 to 1 px into qx dx. So that is equal to integration from minus 1 to 1 px is 1 minus x plus x square plus 5x cube into qx is x minus 3x square dx. Okay, now that dx is missing, but you can understand. Now we have to product of these two polynomials, simply multiplication, right? So that is equal to, the next step is integration from minus 1 to 1 1 into x, that is x, 1 into minus 3x square, sorry 1 into x, that is x, minus x into x, that is minus x square, plus x square into x, that is plus x cube, plus 5x cube into x, that is plus 5x raised to 4. Okay, and minus 1 into x, that is plus 1 into x, x minus x square plus x cube plus 5x raised to 4, then plus 1 into minus 3x square, that is minus 3x square, minus x into minus 3x square, that is plus 3x cube, x square into minus 3x square, that is minus 3x raised to 4, and 5x cube into minus 3x square, that is minus 15x raised to 5. Okay, now some same power of x, the terms which is same power of x, you can together, okay, you can put together. So you can see minus x square minus 3x square, that is minus 4x square. Okay, so this equal to integration from minus 1 to 1 x minus 4x square plus 4x cube plus 2x x raised to 4 minus 15x raised to 5 dx. Okay, and that is equal to, now integration. Now you can see here we use one theorem of integration, one result of integration, that integration from minus a to a fx dx equal to 0. Integration from minus a to a fx dx is equal to 0 if your function is odd, if your function is odd. So here we use that result. You can see x, x cube, that all terms are odd functions, and integration is our minus 1 to 1. Okay, so that's why the value of that integration part is equal to 0. Okay, and minus x square minus 3x square, that is minus 4x square, then okay, so that is equal to integration x square by 2 minus x cube by 3 plus 4x raised to 4 by 4 plus 2x raised to 5 by 5 minus 15x raised to 6 by 6. Integration from minus 1 to 1. So that is equal to x square by 2 minus 4x cube by 3 plus x raised to 4 plus 2x raised to 5 by 5 minus 5 x raised to 6 by 6. Integration from minus 1 to 1. First of all we put 1, so that is equal to 1 by 2 minus 4 by 3 plus 1 plus 2 by 5 minus 5 by 2, and then we have to put minus 1 instead of x. So whenever we change the limit of integration, between that limit of integration we put minus 1, that is the rule of integration for definite integration. So minus 1 into bracket minus 1 by 2 minus plus 4 by 3 plus 1 minus 2 by 5 minus 5 by 2. So just simplify these two terms. You will get 2 into minus 4 by 3 plus 2 by 5, that is equal to 2 into minus 20 plus 6 divided by 15, that is equal to minus 28 by 15. Okay, so you will get the value of inner product with P and Q, that is equal to minus 28 by 15. Okay, and this question asked in 3 marks. Okay. Next question, question 1a, third part. Find the kernel of T and determine whether the linear transformation on T from R2 to R3, where T of xy is equal to x minus y, y minus x, 2x minus 2y is 1 to 1. Now solution. To find kernel of T. Now what is the meaning of kernel of T? First of all, that you have to understand what is the definition of kernel of T. For any transformation T from V to W, where V and W are vector space, the kernel of T is exactly, we have to find such vectors, such elements from the domain such that image of that element is equal to the 0 vector, the 0 element in the codomain, right? So basically we have to find such vectors from the domain, we have to find all the vectors from the domain such that that image of that vectors is equal to 0 element or 0 vector in the codomain, right? So to find kernel of T, here we take, so that's why we take T of x is equal to 0, because we want to find such x belongs to R2 such that T of x is equal to 0, where 0 is a 0 vector in R3. So where x is equal to xy. So T of xy is equal to 0 0 0. Now what is T of xy? That is already defined in the definition, in the statement of this example. T of xy is equal to x minus y, y minus x, 2x minus 2y. So we use that one, x minus y, y minus x, 2x minus 2y is equal to 0 0 0. Now you can compare all the coordinates, left hand side and right hand side. So you will get x minus y is 0, y minus x is 0 and 2x minus 2y is equal to 0. From all of 3 equations you will get only one equation, that is x is equal to y, right? Now let's take x is equal to y is equal to k. Okay, x is equal to y is equal to k. So what is our kernel of T? Kernel of T is exactly all the elements of R2 such that x is equal to y. So here is our kernel of T. Kernel of T is equal to k. Instead theoretically we can write k 1 1, where k belongs to R. Okay, so let x is equal to, so which is our kernel of T. Now another question is it transformation is linear 1 1 or not? That is another question which is asked in this question. Is this transformation is 1 1? So let's try to check. For 1 1ness, what we have to prove? If any transformation T is 1 1, what is our definition? If T of x is equal to T of y, definitely x is equal to y, if T is 1 1. So here we are starting with T of x is equal to T of y and try to prove that x is equal to y, where x and y belongs to R2, belongs to the domain, and T of x and T of y belongs to the codomain. Okay, so to prove or to check that T is 1 1 or not, we are starting with T of x is equal to T of y. So use the definition of transformation, that left hand side we will get T of x is equal to x1 minus x2, x2 minus x1, 2x1 minus 2x2, and right hand side we get T of y is equal to y1 minus y2, y2 minus y3, sorry y2 minus y1 and 2y1 minus 2y2. Now comparing all the coordinates, first, second and third, all the coordinates you can compare, you will get only 2 equations, that x1 is equal to y1 and x2 is equal to y2 simply. Okay, now what is the meaning of x1 is equal to y1 and x2 is equal to y2? Because of our x is x1 x2 and y is equal to y1 y2, you will get x is equal to y. Okay, now so x is equal to y, we are starting with t of x is equal to t of y, and now we got x is equal to y. We get x is equal to y. That means what? T is 1 1 by the definition of 1 1s for any transformation. So here we prove both the terms, that we find kernel of t, and we already proved that t is 1 1. So this question is complete now, and this question asking 2 marks in this question paper. So let's next question, try to solve next question. Question 1b. Question 1a part is complete now. In question 1a there are 3 questions, 1, 2 and 3. First one is asking 2 marks, second one is asking 3 marks, and third one is asking 2 marks. Okay, so total 7 that first part is in 7 marks. Now question 1b, first part. Let R3 have the Euclidean inner product for which values of k are u and v are orthogonal, where u is equal to k1 and v is equal to k5 6. Now what is the meaning of orthogonal in Euclidean inner product? Here is the definition, that if u and v are orthogonal, then norm uv is equal to, inner product of u with v is equal to 0. Okay, inner product u with v is equal to 0. So we want to find the value of k. Now u and v are already defined, so inner product u with v is equal to 0. That means inner product u k1 with k5 6 is equal to 0. Now here we have to use Euclidean inner product. So inner product means just simply dot product, right? So dot product of k1 into